Hello, everyone. Connectivity is key on our daily life. And because we, Ericsson, want to connect with you, we have created a set of events on which we will be showing you the 5G technology. The first of these events happened on the 11th of May, and they are called the Ericsson Unboxed Office. In case you missed it, we bring it for you. Please stay alert, and if you have any questions, post it on our chat, or you can wait for our Q&A session, because we will have one of our business builders with us today. He will be able to answer any of your questions. If you are interested on the complete event, you can check the link on the chat, and you can take a look. Thank you for joining us.
In this demo, we try to explain how important a mobile operator is throughout the life cycles of connected things. We also try to show how different the needs are through the connected device perspective when it comes to their life cycles. Enjoy!
So what is the potential of IoT and 5G? Well, if you don't think that 5G can anchor new business cases, let me stop you right there, because when we look from a mobile operator's perspective at IoT, it looks pretty impressive. So we've taken the chance to look at the life of a car, the whole life cycle of a car. And if you can anchor into all of these kind of cases where the car is connected throughout its life cycle, then you have a lot of business there. And when we talk about life cycles, we have to start with the birth. Here is a car factory. A typical car factory today resides on something we call Industry 3.0. Let's say you have 10,000 square meters, and inside there is about 1,000 robots, all individually connected with their own brain, their own PLC. So you got a very efficient factory, but you don't have a flexible factory. You can't change what you produce very quickly, for instance. Industry 4.0, or smart manufacturing, is where we bring in our power. 5G can deliver as good and as reliable as a cable. So if we can remove all the cables, we don't have 1,000 points to reprogram. We have 1 point, one brain, and that will change the whole factory floor and what you produce. You also have automatic guided vehicles today, often going on a rail that needs to be reprogrammed. Well, 5G delivers precise positioning down to centimeter level as well. So here you can see the factory as it is, but also digitally copied up into a sort of cloud environment. And that's where you can bring in supply, you can bring in research and development, manufacturing, and transportation into one homogeneous layer, if you will. So smart manufacturing will exist, but it also will need 5G. The module inside the car that will later be used by the driver is here used to make the car. And as it's transported out of the factory, then we transfer that module into more of a transportation or logistics module. And that is the next step in life of a car. So now the car is transported out of the factory, and we switch the module over to be used for more a logistical purpose and into a port. Now, remember, about 90% of all things we produce are shipped through ports. So these are really an important customer for you. And it pushes the need for the network to be really, really tough here. That's why we see the private networks coming into hand here. In a port like this, many things are automated, and for instance, automatic guided vehicles are there. We can see the need of a traffic tower, even though it's very much automated, because if you have these automatic guided vehicles or autonomous vehicles and there is something strange that happens, in this case birds is in front of it, it will completely stop. And it will be very unnecessary to go down there and fix the problem, but instead using the traffic tower and remotely connect to a vehicle. But if you're remotely connected to a vehicle, it better be very reliable and very fast, especially if it's among other people. So shipping the car is the next step. The module is switched over to be used for logistics purpose. Next step is to activate the car, and that's over here. So here is where we activate the car. Now you need a global offering, for this is happening all over the world. Cars are sent anywhere and everywhere. It's very similar to the water pumps of Grundfos, actually. They are sent all over the world and continuously extracted information from by the water companies. So activation might mean activation of software that it needs to be upgraded to the car using that same module, but also different services that are wanted by the one who buys the car, Spotify and other entertainment services. Next step is see the car in action, and that's over here. Now, I just want to mention a little bit about autonomous vehicles and autonomous driving in specifics, because that's a 5-step ladder, where step 1 is things like cruise control and parking assist. Step 2 is hands-off, and we do have those kind of cars today. But when we move into step 3, which is actually eyes-off, and step 4, mind-off, you can take your little nap in the car, or step 5, which is steering wheel is optional. Well, then we need not only the cars to be very smart, but the surrounding to become very smart. We need cars to be able to talk to other cars. And in 5G, we call that side link or vehicle to vehicle. We need cars to look around the corners, and radio can do that. So cars can be warned that there is a danger ahead. We need a traffic cloud kind of situation where cars teach other cars that the ground is actually dangerous in front of me. So that kind of environment, we foresee 5G can deliver a lot. Now, if you imagine also going a bit rural here, there is about 200,000 kilometers of road in Sweden which is not covered today. So if the car is aware of the network quality ahead and it knows where you're going, it can, for instance, download quickly where it has good connection, a movie, and then you can enjoy that on those rural roads. Or it can suggest an alternative route if you still want to be connected continuously throughout your trip. We can also see that features can be altered in vehicles. For instance, slippery ground might be higher suspension in the car, or hilly areas you might want to have more horsepowers. But in flat ground, you don't want those horsepower because they consume too much diesel, for instance. Now, let's move in to the end of the car. So now we're talking about end of life. And recycling of all materials in a car can be done much more efficient if we know the history of the car. You need to recycle the materials, but not only the materials, also the IT components need to be recycled and decommissioned, or possibly recommissioned, depending on their status. So what I'm saying here is that we can have a much more efficient recycling process if we know the history of the car. Now let's bury this car, may it rest in recycled pieces.
Since 1981, mobile communication systems have been one of the most important inventions that we use every day. In this demo, we try to show how voice is being evolved by implementing voice into the Internet of Things.
You know, Lars Magnus Ericsson once said, communication is a basic human need, and boy was he spot on. Since 4G was introduced into the markets, VoLTE and these kind of services has constantly gained momentum. It's just so much easier to just push a button instead of downloading specific apps. So now we are introducing something called the Ericsson Communication Accelerator, which is as a service, cloud-based, 5G-ready communication tool, if you will. So for a company like a scooter company, that would deploy maybe 10,000 of these scooters, you need to have all these devices pre-configured with all the kind of services that they're needed for. For one thing, if I can't just pick up a scooter that is close to me or leave it wherever I want, then it doesn't work. So we really need the cellular network to support this. So we're now introducing VoLTE in these kind of devices as well. But they need to be pre-configured. There is no fancy screen or any dial system here. So pre-configuring thousands of these is an easy task when you use the Ericsson Communication Accelerator. So why should we use voice? Well, it could be just a simple task that you want to call up the scooter company and then they will answer whatever question it is. But we also said, well, what if I fall? It falls and then directly dial to the emergency service with a position on where I am. So this is a very fast way to introduce new services in these kind of IT devices using VoLTE. So that is exactly what Ericsson Communication Accelerator is all about.
When you made something yourself and sold that was called Industry 1.0. In the early 20s and 30s, factories was introduced, and that was called Industry 2.0. When we add computers to that factory, we turn that into Industry 3.0. And that's where we are today. A factory with 1,000 robots has 1,000 brains and 1,000 cables. Now comes 5G, and we're introducing Industry 4.0. This demo will show how 5G can replace 1,000 cables and turn 1,000 brains into one. Enjoy.
Industry 4.0 is an enormous step for industries, but also a huge leap for factories. Broadband IoT and massive IoT came with 4G, but critical IoT and industrial automation IoT, that comes with 5G. This is an example of our collaboration with Audi, and it shows the true value of URLLC, or Ultra Reliable Low Latency Communication, which is a set of tools, toolbox if you will, that comes with 5G. So what we have here is a robotic arm sitting inside a mobile unit with a laser curtain that detects any movement. It stops the robot instantly. Remember what I said in the beginning there though. We do have brains connected with cables today to robots, but this one has a central brain somewhere in the facility of the factory, and it's connected through URLLC and 5G. And it's happening within 1 millisecond any instructions. Any movement of the robot is also done from the computer brain and sent through the URLC network into the robot arm every 4th millisecond. And it's also been decided that as long as we stay under 12 milliseconds, this function will work. But it is actually 1.2 milliseconds, this latency. So if I stop in my hand here, it stops within 1.2 milliseconds. That's obviously for safety. But URLLC also stands for high reliability. So if I move my head in here, it stops as well. So that is a little bit around URLLC and Industry 4.0. Thank you.
Every new release of a mobile generation has been also the release of new hardware, architecture and software. But 5G is about reusing and recycling. Ericsson Spectrum Sharing will let you reuse your spectrum and your hardware that normally is used for 2G or 3G or 4G, now to be used for 5G as well.
Ericsson Spectrum Sharing is such a fingerprint of what Ericsson is all about. I mean, if I can take a piece of hardware from 2015 and just software upgrade that and it runs 5G, that means that somebody knows what they're doing. So we predict that more than 80% of our customers will start to use Ericsson Spectrum Sharing within the 12 months. Maybe that is why we got the GSMA Global Award for this. Okay, the setup here. We have a radio over here. It's set on 1900 megahertz. It's called the 4442 for you who are interested. And it runs still with one single cable, CPRI cable, the yellow one, to the baseband. So the baseband is running 4G and 5G at the same time. It's basically a software upgrade on your existing site. And if it is from 2015 and forward, you can do that. On the screen over there, you can see that the 0 to 100% is a 10 megahertz carrier, which is sharing traffic between the 5G device and 4G device. The switch is within a millisecond, so this is instant. So how is Ericsson Spectrum actually used? Well, obviously you get coverage of 5G in low frequencies, but when you carrier aggregate it with, for instance, a midband, we not only get a homogeneous cell, we get extended coverage in the midband as well, because you run all the uplink traffic and the uplink throughput on the low band. So you basically extend the cell as well. Now, talking about energy consumption in a network, breaking the energy curve is something we can see happening for the first time. What I mean by that is, since 1981, traffic and energy consumption has gone parallel. So as traffic increases, energy consumption increases. Well, we can now see that we can break that energy curve, even though traffic extends. Now we're looking at the whole traffic of the whole network. And Ericsson Spectrum Sharing is one of the big contributors in breaking that energy curve. I had an operator here who said, John, 80% of my energy goes to 20% of my traffic. But on the other hand, 20% of my energy goes to 80% of my traffic if they remake it. So it's a huge thing, Ericsson Spectrum Sharing. Saving energy while keeping the reach of 5G, that's the essential part of Ericsson Spectrum Sharing. And that's what it's all about.
In this demo, we'll show how AI and automation will help an operator operating their network, which is becoming more and more complex. In this demo, we'll show how AI won't replace people, but rather help a workforce doing impossible tasks in a complex world. Enjoy.
Operating your network is a tough job. Believe me, we know, because we are operating more than 1 billion consumers daily. And now we're adding one more G, So complexity has grown enormously in the last years. What we're talking about here is AI by design, looking at the whole network and what could be implemented with AI. So AI has gone from a more more reactive kind of feature to more of a proactive. And we are somewhere around here right now. So going from machine learning to machine reasoning is the next step. These kind of algorithms are used daily today. I think we have around 40 running on our own networks. But we are aiming for about 300 in 2022. So if we have a look at a few of them, improved customer experience is one of the common problems that we need to solve quickly and with AI. Here is an example, KPI degradation and prediction for RAN. So you're running this as an AI algorithm on your network, and we can predict at least 2 hours ahead if there is going to be a problem service-wise in that network. And that makes us be able to act upon that before it happens. And that saves CapEx, actually. Now, looking at AI, see it as a brain with two things, knowledge and reasoning. And our brain has about 1 billion reasonings per day, globally and in 4 continents. So thinking further ahead, we are planning to have a federated learning into one central place. Federated learning means you don't forward any data, but just forward the understanding of how to solve a problem. And even though there are standards out there, they are a bit different depending on if it's on a continent there or a continent there. So federating that into one brain, you get a very smart central brain. And few other companies can do this, but having this global reach. So in the end, you might see it as a kiosk where you just subscribe to a new understanding, and that understanding has been taught by all the small understandings around the world. So to sum up, going from reactive to proactive is not only important, it is a necessity in this world where the networks are getting more and more complex. Thank you.
Sharing our experiences we've gained after deploying, up until May 2020, 32 live 5G networks is actually a demo. Well, it is a story anyway, and it will be very different depending on your interest or your questions. But here is what we can share, an example. Enjoy.
As Ericsson is a global company, with that comes global knowledge, but also global challenges. We're proud to be supporting, up until today, 32 live 5G networks in 4 continents. And the focus has clearly been on end consumer business. Now, we've had 3 key learnings by doing this. One is how to expand your coverage, one is to boost your performance, but also how to introduce network architecture which is standalone. Now, we know that with the coming 12 months, more than 80% of our customers will be using Ericsson spectrum sharing. And we also have the largest support of 5G devices, more than 40 of them around the world. My point being, we have the knowledge for you to create value in 5G. Come to us and talk to us. Now let me focus in a little bit on one of our customers, Telstra in Australia. So Telstra has a strategy that is 10 cities with 5G coverage in the central areas, and then expanded within 12 months to 35 other cities. And then very early on, they want to expand new business cases because that's what 5G enables. So Telstra had very clear goals. They wanted to be first with 5G in Australia, check on that one. They wanted to lead by having exemplary enhanced mobile broadband performance with plans and devices in propositions, check on that. They wanted to be first in market with 5G smartphones. And what's also interesting is that really early on, they want to explore new business cases, which is exactly what 5G does. So once again, my point here is, please come to us, talk to us. We have the experience and the knowledge and the know-how of how to create value in 5G. After all, 5G is made for innovation.